Meeting is being recorded.
Good evening. I am Rayah Al-Shahrani, and this is Space Talk from Riyadh. Thank you for joining us, for those subscribed on Zoom and who are watching us live on Twitter. Humans from the ancient times have always looked up in the sky to learn the direction of their ways on Earth. They had always used stars to help them navigate while sailing or traveling on land. It's only when they were able to go to space that they learned how to make a better life on Earth. In today's talk, we will look at one example, the Indian space program, how it's all started, and the Indian Earth observation program, the evolution of imaging technologies, and etc. We will be discussing the application for meeting the national imperatives, governance and citizen-centric services for improving quality of life. The talk will also touch on aspects of international cooperation in such programs. I'm excited today to have this discussion with our guest, who will be sharing the stories and the knowledge about the Indian space program. He is a scientist responsible for steering the Indian Space Research Organization programmatic activities and the interministerial interactions related to Earth observation applications and disaster management. He has more than 35 years of experience in the areas of remote sensing, digital image processing, information systems, and decision support systems related to natural resources and disaster management. He coordinates space applications activities toward the conduct of proof of concepts, satellite utilization programs, and the operational applications at the user end. Ladies and gentlemen, join me welcoming Mr. Shantanu, scientist and the director of Earth Observation Applications and Disaster Management Support Program Office from the Indian Space Research Organization in Bangalore. Mr. Shantanu, welcome. It's my pleasure to have you on Space Talk.
I hope my slides are visible. Presentation is visible to everyone.
It will be visible very soon. And before we start our discussion, I would like to ask our audience if they have any questions throughout the talk and the presentation. Please type them immediately in the questions and answers below, and I will be asking them immediately for our guest at the end of this space talk. Let me start, Mr. Shantanu, by asking you to give us a brief on how the Indian space program started, the motives, the driver of such programs.
Basically, first of all, good evening, everyone in Saudi Arabia. And at the outset, from the ISRO side, I thank everyone for giving this opportunity and basically to highlight the achievements of the Indian Earth Observation Program for national development and governance. Coming to the question you asked, basically the vision of the Indian space program led by Dr. Vikram Saraf, and since the inception of the space program, the vision has been always application driven. That means the utilization of the space technology for the real problems of common and the society. With that vision, we have started and from the stage in early 60s till today, the main primary driver for the space program, including the Earth observation, communication, or navigation, has always been in socioeconomic development as well as for the governance. So,
Yes, please go ahead.
Okay. So I'll be briefly talking about the Indian Authorization Program for National Development and Governance, and specifically highlighting some of the examples how it has really benefited the development of the country and also the citizen-centric applications, ultimately improving the quality of life of the citizens. So just now, as I told, the vision of the space program was led by Dr. Sarabhai with an intent that the application of the space technology should be used for the common problems of the real man and the society. And we started our infant stage in by launching the first rounding rocket in 21st November 1963 with the collaboration with France with a small fishing hamlet. And from then onwards, the vision of the space program, basically to serve the society, has been sustained, has been nurtured, and has been enriched with many more applications. This is the evolution of the space program, where in the early 60s and 70s was our initiation phase. We started with the vision, we started with the scientific quest to explore the space for the mankind. And then in the 1980s, we started the journey of the experimental phase, where we started building the experimental satellites, experimental payloads, and also started prototyping them and building small satellites and the payloads and the rockets. Then in 1990s, we started the operational phase, where we have the operational launch vehicle missions. We started the state-of-the-art operational satellites, and also started delivering national services utilizing the capabilities of the satellite technology. And now, of course, in 2000 onwards, we are expanding the space with more and more innovative missions, more newer services, and also the global outreach. So the vision, which started with harnessing the space for the national development, we also added now in the vision that while pursuing the space science research and planetary exploration. This is the accomplishment in space as of now. We have done almost 196 missions, which includes the launch vehicles, the satellites like remote sensing, communication, navigation. We have done the space science and interplanetary missions like Chandrayaan 1 and 2, the Mars orbiter mission, and the AstroSat. Our polar satellite vehicle is a workhorse, and it has the capability of launching 750 kg payload, or you can say a satellite, into the sun synchronous orbit. Then we have the geostationary satellite launcher, which can take something like almost 2200 kg satellite to geosynchronous transfer orbit. And our heavy lift launcher, the GSLV Mark III, has a capability to take 4000 kg of the payload into the geostationary transfer orbit. As of now, we have launched 112 satellites and 82 launch vehicle missions. And the Polar Satellite Launch Vehicle has also launched 342 satellites from 34 countries. If you really come to the vision and the verticals of the Indian Earth Observation Program or Earth Observation System, our vision is basically to enable national development, improving quality of life, and building a resilient society, but particularly for the disasters and better understanding of our system. We have 4 verticals: the space segment, ground segment, space applications, and institutional linkages. Few of them I will cover in detail. In the space segment, we have the very strong constellation of the satellites for natural resource inventory and monitoring, for disaster management, ocean and meteorology, and also for cartography and mapping applications. In ground segment, we have the very vibrant data acquisition and processing system, where we have the capability of almost processing something like more than 2000 data products per day. To supplement the data from the space, we have large number of in-situ observation network in terms of Doppler weather radars, automatic weather stations, carbon flux towers, even ocean buoys, which gives basically enormous amount of data to complement the data which is coming from the satellites. Large number of space applications have been built basically to address the national imperatives and the socio-economic transformation which we have been constantly building in the country. And very, very strong institution link. ISRO actually works very strongly, very closely with all the ministries and departments in the country, with the industry and academia, and international cooperation is also one of our very, very strong forte. About how we evolved the imaging technology. So as I told when we started the operational remote sensing in 1988, our very first time when we launched the satellite, we had a very innovative technology called the push broom technology. Before that, even the satellites from the US and other countries, they used to have the scanning mechanism, multispectral scanner, which used to have a mechanical components, or you can mechanically they used to scan their surface. Where in push broom, we had the linear array of the charge coupled devices. So this was even an innovative device or innovative technology, even at the beginning of our operational. We gave the world a 3-tier imaging capability. That means from the same platform or same satellite, we are able to have 3 different kind of resolutions. So from starting from 188 meter to 50 meter to 6 meter, from the same platform, you can get different type of images. Then we had in 2005, we have given the world the stereo imaging, first stereo imaging satellite in the world, which had the resolution of 2.5 meter. So at the resolution of 2.5 meter, we could generate the stereo imaging. And added or augmented our capability, the scatometer with the microwave or radar imaging satellite, which gave the capability for all weather imaging, and also the altimeter developed in collaboration with France, basically to get the sea surface wave heights. And if you see, even in the meteorological satellites, we have grown from INSAT 1 series in 1983, which used to give only 4 images per day about the meteorological parameters and the meteorological observations. And today we have come to INSAT 3D series, which almost giving 48 images per day. So this is the kind of augmentation we have done in our capabilities.
Yes, if you allow me,
if you see,
no.
Yeah,
I'm interested on the products that was made on the 80s, because in the previous slide, you mentioned that in the 60s to the 70s, you are starting to build up the capabilities, but in the 80s, it's like end-to-end capabilities. And so I'm interested in these satellites, which were built in the 80s, like, was it full capabilities within India to produce these satellites?
Yes. So when I was the technology for which we have built the remote sensing satellite in 1988, yes, we can say that the entire satellite was built indigenously. But yes, you can say the charge coupled devices or the detectors were imported, sometime from France, sometime from Germany. But the entire capability of the building the satellite was totally indigenous.
Great.
And this is our current observation capability. And these are also all the satellites which are built totally with indigenous capabilities. Of course, we have certain electronic components and maybe some of the detectors, taking from the foreign countries' assistance. So we have right now, like resource monitoring, we have the capability of 2 satellite, ResourceSat 2 and 2A, which gives the imagery at 56 meter, 23 meter, and even at 6 meters. So you can see the difference in the resolution. Today we have a very large scale mapping capability, wherein you can see the image at 1.5 meter resolution and also at 0.4 meter. That means something like 40 centimeter imaging capability have been built by India. And this particular satellite has almost got something like 2 meter optical mirror, which also has been indigenously fabricated within the country. Then we have the capability for monitoring the ocean color and also the ocean surface winds, which is very, very important parameter for the cyclone monitoring as well as for the meteorology. And for meteorology, we have the 2 dedicated satellites called INSAT 3D and 3DR. And every 15 minutes, you get information about the various meteorological parameters. So what exactly Earth observation can do for the national development and the governance? Certainly, it can provide vital inputs to leapfrog in the development. It can act as a catalyst for economic development. and also it can serve as enabler for bringing a societal transformation. But really, if you want to have the impact of Earth observation, and if you want to see that the application of Earth observation penetrates into the government, penetrates into the like other industries or even academia, you have to have the policies, the reforms, and the procedures. So at the one end, we have the end user, which is basically waiting for the application of the technology, and one side we have the policies. So until unless we marry these two, you have the policies which are eco-friendly, ecosystem friendly, then only the benefit of the applications can reach the end user. So in India, we had since the beginning in 1980s, we had a framework called NNRMS, that is called the National Natural Resources Management System. And this was a system wherein all the ministries or all the government departments, which basically envisages to use the space technology, are the members in this body. Similarly, the academia, which uses the space technology, they are members in this body. Similarly, the private entrepreneurs, okay, other even ISRO centers, they're all part of this. It is like a big network. And with this network, basically we used to discuss what kind of satellite, what is actually the demand from the user, what kind of satellite the user needs, what kind of satellite the ministry needs. And based on that, only the satellite is built and the applications are developed. And so if you can see now, now in the country, this is a very important slide. In India, we have a very strong system that is called the Space Application Management System. And this is recently also the communication satellite and navigation satellite also has become a part of the system. So you can see the entire system has got the standing committees, which is chaired by the secretaries of the government departments. So we have like committees on agriculture and soil, the water resources, the geosciences, urban and cartography. So all the institutes who are involved in this, they basically tell ISRO that yes, this is the kind of satellite I want. This is the kind of application I require to be developed. And based on that, we design the payload, we translate the requirement into the payload and the satellite, and then also build the applications. And this entire system is being chaired by the principal scientific advisor to the government of India, who works very closely with the Prime Minister of India. So this system actually has been very successful since the 1980s, and it has really led to many applications, which has not only been adopted by the ministries, and now the ministries are using those applications operationally at their end. So I just would like to show some of the examples wherein the space technology we are using for the socio-economic security, for sustainable development, for disaster risk reduction, and also for the governance. But if you can see here, what I wanted to show here is, in India, yeah.
Yes, if you allow me, the NNRMS approach, was it a way of dictating the policy to regulate the space ecosystem, or was it just a project to receive the inputs from the end users?
No, NNRMS basically is an apex body. You can, as I told you, the various user ministries would like to utilize the space technology inputs and to their benefit, and how really they can, how the applications of the Earth observation can benefit them in improving their applications. So they are all party to this. So they give basically the requirements, kind of satellite or payload should be built. But as far as the policy is concerned, yes, we have a different body. Basically, so this entire NNRMS system, slide, we have in India the operational ministries. That the technology. ISRO has developed the technology, developed the applications, and then transferred to the ministry. Now, ISRO no longer carries out those kind of applications. The user ministry at their end, let us say agriculture ministry, they are doing their the technology. We have built the application. We have done the capacity building. Forest. We have transferred the application of the entire forest mapping. Biennially, every once in 2 years, map the entire forest of the country. Similarly, talk about the irrigation potential. Every of this, there are certain ministries who have joined late, still who do not have the capability. Still, ISRO does the building more and space technology cells in every ministry. So about agriculture, how we really enable the food security. So we have 4 major programs with Ministry of Agriculture. The first one is called the pre-harvest crop forecast or crop production estimation. That means when the crop is sown and before it is harvested, multiple times during the crop growing season, we tell or we give the forecast that how much is going to be the agriculture production. So once you have sown the crop until it is harvested, you get almost 3 to 4 times, almost you can say every month, that how much is going to be the production. And this operationally we are doing for 8 crops, 8 major crops in the country like rice, wheat, mustard, sugarcane, jute, and pulses. So this is an extremely important program which basically helps the Ministry of Agriculture to take the policy decisions on procurement. If you have any deficient or you can import it. If you have excess or surplus, you can import it. So it takes make policy decisions. Similarly, this is about the food grain crops, but when you talk about the horticultural crops, when you talk about fruits, vegetables or the spices, so we have a big operational program called Chaman, which basically talks about the site suitability for these crops. That which are the areas where you can really go for the horticultural crops. So it helps the farmer in a very big way that once he gets to know that this area has got a horticulture potential, and he gets a sort of additional land. Similarly, in entire country, we monitor the wastelands and degraded land. Every 2 years, every 3 years, all the wastelands in the country are monitored, so that those land and then they can be brought under after doing the reclamation measures. So these are kind of programs which really helps not only the ministry but also helps the farmer. If you really say which are shown here, the bringing green revolution to Eastern India. So what is done here is a very innovative approach. So once the rice crop is grown and once the rice is harvested, so a lot of soil, a lot of moisture is available in the soil. So we identify those areas where you have sufficient amount of moisture, and that area can be used to grow short duration pulses. So it gives an additional income. The farmer is actually growing only the rice, and rice is harvested, but the soil has got still moisture that it can sustain one more short duration crop or short duration pulse crop. So we identify those areas, and it has given immense benefit for improving the livelihood of the farmers. You see, this is another innovative application. I'm talking about the fishermen. So wherein not only the earth observation, we also integrated the navigation, satellite capability. So in India, we have got 7,500 kilometer long coastline, and almost 7 million people are dependent on fishing. So using the data from the OceanSat satellite, which gives information about the ocean color, that means about the chlorophyll, that means what is the kind of vegetation or the chlorophyll is available on the ocean surface. So these are the areas or that chlorophyll or the phytoplankton acts as the nutrient for the fishes. Those areas are identified so that you have likely a chance of getting a more fish there. Similarly, the sea surface temperature you identify. Everywhere you will not get a fish catch. The sea surface temperature also has to be conducive where you will get the better fish catch. So utilizing these two, integrate information on every day basis. The information is given to the fishermen that okay, you need to go in the sea in this particular direction. We also navigate them by giving the information of navigation on their smartphones. So they navigate to that place and they get a better fish catch. And this has increased, their fish catch by almost 3 to 4 times, and also saved their search time because they don't have to go here and there searching the fish, or even the search has been reduced by 60 to 70%. Satellite, what we added is, whenever the fisherman is going in the sea, sometimes accidentally he approaches, before 2 kilometers before he is going or approaching this border, the warning is given, alert on his smartphone that you are just very near to international border. So this is a very holistic of application, which has really not only improved the livelihood of fishermen. At the same time, if you see talk about the water resources, every 15 days in the country, we generate the water spread map, the surface water spread map. How much is the availability of surface water in the country? For the entire country, these maps are generated every 15 days. Similarly, the canals, the waterways are also monitored when they are being built, and after they are built, how much optimally they are being utilized is also being monitored by using the Earth observation satellites at a constant interval.
I have a
question. The most important application, yeah.
So these services are provided to local fishermen, or to like private companies, or to the ministry, or?
As I told you that this technology was developed by ISRO. Later on, this technology we transferred to the Ministry of Earth Science, and they have a dedicated center called INCOIS in Hyderabad, which every day gives this information to fishermen. Now, basically, they provide this information to the fish landing centers. All along the coast in India, we have got 1,200 fish landing centers. So this information goes to them in the form of email, in the form of images, which is displayed there. Also, the information goes on the smartphone of the individual fisherman. But now there are many industries, yes, they are also interested to get this information and develop some more innovative application on the information which is already provided by ISRO. But whatever the devices, what I've shown you here, which is built for this application, they have been totally built by the industry partnership.
All right.
Yeah, one of the most very most important application and which has been very successfully utilized in India has been the groundwater prospect. In India we have many zones which have the habitation, problematic habitations, where we have the problem of groundwater, and you don't have proper drinking water as well. So we have really exploited the potential of the Earth observation satellites in terms of mapping various themes like geomorphology, aquifers, the structures, the hydrology, the drainage pattern, and then integrating all this information. We have been building the groundwater prospect map. So this map not only shows where you have the possibility of getting a good groundwater, but also it gives information about the depth, at what depth you will get the groundwater, and what is going to the yield. Minute, how much liters per minute of yield you will get of the groundwater if you start the exploiting water from. This is one way for groundwater exploitation. Similarly, the Earth observation satellites are also used for locating these structures, where you can locate and build the recharge structures, so that the groundwater can not only be exploited but also can be recharged again by or through the rainwater. So this is a very unique application, and so far in India we have drilled more than 3.5 lakh villages wells using this, with an accuracy of ranging from something like 85 to 90%. And such maps are available in every state of the country in India. Similarly, this one more example is of the energy potential. Now we are giving very at regular interval, almost you can say every 24 hours to 48 hours, we are giving the forecast of the potential renewable energy, particularly the solar energy, and also the wind and wave energy. So this is also available for the industries, for the ministries, such kind of information where industry is interested to put the solar power plants. So they need to know that which are the areas which are going to have the maximum solar energy. Also throughout the year, starting from January, February, March, every month, what is the the kind of potential that area has in terms of the solar energy. So the solar calculator has been built, which is also available. You can see on the Google Play Store. Anybody can download that and really see in India that how much at that particular location in terms of latitude and longitude, what is the solar potential availability, which really helps the industry and the people who are really going to install the solar power. Similarly, one about the air quality and the health. This regularly monitor the movement of dust, basically from the west to east, how it is moving, and also whenever there is a forest fire, so the smoke which is generated or the is generated using by the agriculture burning, that also is regularly monitored, because this really causes the health hazard for our respiratory systems. It also causes the damage to the cardiovascular system. So this is also monitored at PM 2.5 and PM 10 scale, particulate matter, and provided the information to the Ministry of Environment, Forest, as well as also available to the citizens. Now let me just talk about the next component. This was about the socio-economic security. The other component is the sustainable development, which is basically really to conserve our ecology. In India, we have a very operational program that is called the NR census, like human census, where in the population is counted every 10 years. So similarly, in India, we have a program called NR census, wherein we do the assessment of natural resources every 5 years, or many of the resources even every year, like land use, land cover. So the entire land cover is mapped every year, also 50,000 scale, and every 5 years larger scale at 50,000. The forest cover mapping for the entire country is done once in 2 years. We do the land degradation mapping, wasteland mapping for the entire country every 5 years, and similarly like snow and glacier mapping, and also the mapping of glacier lakes every season, starting from January till you have the season of June. Similarly, you can see here the forest mapping, where as I told you, the Forest Survey of India does the biennial assessment of the forest, and also the biodiversity mapping, where more than 125 to 150 species of the forest have been mapped. Of course, you can't map the species of the forest only by using the observation satellite data. You also need to have a lot of ground information, but by correlating that, you can also do the species mapping for at least at a larger level. You can say something like 125 to 150 species have been mapped, and this map is extremely useful for the conservation of the bioresources, how to conserve them from any illful impact of the anthropogenic or from the human-induced activity. This is another important program. I will just show you here, wherein we are involving each and every farmer or the villager in the country. That is why I'm putting it the title called Empowering Grassroots in Development Planning and Decision. That means for every village, we have the information on the natural resources. We have information on the socio-economic conditions. We have information about the various themes in terms of land use, the drainage, the slope, soil, water resources. And integrating all this information, we generate two sort of developmental plans. One is called the land resource developmental plan, and other is called the water resource development plan. That means utilizing all this information, we can say that this piece of land has the potential for growing, let's say, agriculture. This piece of land has a potential for growing, horticulture, or it is good for socio-forestry, or this particular land is not useful for doing any sort of development. It can be used for any industry or any urban development. So in this particular endeavor or this particular operational application, we are even involving the villagers who have their traditional wisdom. They have been doing the agricultural practice in the village for many decades. So how they are doing the practice, their cultural practice also is integrated, and such maps are being developed. So we have got something like 2.5 lakh villages in India. So for every village, we have this kind of developmental action plan. which is developed every 5 years.
And so do you validate the scientific data with the wisdom of villagers?
Yes, we basically also use, we don't basically the thing is, we don't have that many governmental lands in the country. So you really cannot impose on any farmer that whatever I am saying you should grow, because ultimately he will see his economy also. So we need to teach them that if you follow a scientific method of agricultural practice, your land will sustain for a long time. Your fertility of the land will be there for a longer time. And also you'll have, if you are taking a single crop, but your land has a potential to take one more crop. So it will give you economic benefit also. So it also requires, a lot of capacity building, a lot of interactions with the villagers, teaching them through their local languages. So one side, yes, we are developing the scientific database, but at the side, we also take the help from very educated people in the villages who can really convey in their local language what is the advantage of these scientific maps.
Great.
So now let us talk about the disaster risk reduction. This is another vertical where operationally we are using the Earth observation satellite data. And this is a program which ISRO does in collaboration, a very close association, we can say, with Ministry of Home Affairs, which is the main ministry, which is basically mandated for the disaster management in the country. We work with the NDMA, National Disaster Management Authority, also with the Ministry of Agriculture, and of course the Cabinet Secretary. So and we basically try to help in the disaster reduction in all phases of the disaster. You start from the preparedness, start from the response, rehabilitation, mitigation. So all the phases of the disasters we have been supporting operationally to the various disaster management agencies, because we have the observation platform in terms of satellites. We have the aerial platform where we have also 2 aircrafts, with a lot of payloads which can collect the information. We have the databases at various scales, starting from 50,000 to 2,000. Even some of the mega cities in the country, we have a database which is at 1:2,000 scale, which is very, very helpful during the disaster management. And we also have, ISRO has also built the emergency communication systems like satellite phones, like the distress alert terminals, so that in the event of disaster, if the terrestrial communication fails, we can switch over to the emergency communication supported by the satellite. And we are, of course, now doing the applications for floods, drought, cyclones, forest fires, and of course some preliminary studies on the earthquake as well. So our primary job, basically ISRO's job, is to bring the technology to the people through all the ministerial agencies who are involved in disaster management. So as I told you, we have the capability of making the hazard zonation maps. So you can see the flood hazard, landslide hazard, the drought hazard. So these maps are basically developed using historical data. We have the database for the floods or for the landslide for the past almost 30, 40, 50 years. So these maps basically tell you that the areas which are frequently flooded, the areas which have got a danger of flood if this much amount of rainfall occurs. So these are called hazard zonation. That means we are only giving the alert to the ministries that, okay, in case if the intensity of rainfall is very high, these are the areas likely to get flooded. Then we have the operational early warning system for the cyclone, which has been very successful. One example in India, when we had a super cyclone in 1999 in Odisha, we lost more than 10,000 people's lives. And now after this Earth observation satellites and building and cyclonic operational system, we can say that the loss of lives have come to single digits.
And so how do you get this program?
Sir?
Yes, so here in this program, how do you do the governance of such a program?
Yeah, basically, as I told you, the Ministry of Home Affairs is the main agency which is mandated basically for the response and the rehabilitation. Whereas there are other ministries, like if you have drought in the country, Ministry of Agriculture is the agency which takes care of drought. Similarly, in the case of flood, we have the Central Water Commission, which gives the warning about the floods. As far as cyclone is concerned, we have the Indian Meteorological Organization or Meteorological Department, IMD, which basically gives the warning. So what we do using the satellite data, and we have built the applications. We have built a cyclogenesis model, which basically uses the information from the meteorological satellites, from the oceanographic satellites, and then it predicts the track of the cyclone. That cyclone, when it has built in the ocean, how it is, continuously we monitor the track, intensity, and what time it is going to hit the coast. So this information every half an hour, every 1 hour is being, updated and provided to the ministry, which in turn the Ministry of Earth Science will give the alert on the cyclone warning. So this is the entire model. Basically, the methodology and the technology has been developed by ISRO. Whereas the flood alert is concerned, we have only on the experimental stage. So far, we don't claim that we have made any operational application as far as the flood is concerned. We do have some of the flood warning systems only for two major rivers called Godavari and Tapi in India, but we don't claim to have this system like we have for cyclone at operational level.
And what are the challenges that made it not possible to have an operational system for the flood?
The problem with the cyclone is why it is a little easier to do because you have the satellite which is geostationary satellite one, which is basically at a height of 36,000 kilometers from the Earth's surface, and every 15 minutes to half an hour you get the information about the meteorological parameters. So very closely you are able to monitor. Whereas in case of flood, one is the satellite basically generally information you are getting from the low Earth observation and the satellites. Basically once you are in the LEO orbit, you don't have the kind of repeativity every half an hour. You can get data maybe once in 5 days or once in 4 days. That is one aspect. Second thing, basically to really tell how much is going to the flood and how much is going to the runoff of the flood, you need to have the configuration of the river to be studied in detail. The entire morphology of the river, the entire river configuration, how much is the depth at at various levels of the river, you should know very well. You also have to have the discharge data very accurately, the discharge data. So you need to have a very large number of discharge stations which can give you the information from the ground. So it is not as easy as you can really do for the cyclone.
All right.
So this is telling you that is why we have written only experimental flood warning. We have the data for many of these rivers and all. Still, we are only in the experimental stage. Only, as I told you, for the 2 river basins, only we could make it operational because it requires huge amount of data and very, very large scale maps of the rivers. Then similarly, even for the landslides also, we have the you can say early warning system, but this is only for the rain triggered landslides. That means we have the database with us. We know where the kind of slope you have on the hills, which are the areas which has got loose soil or where slope stability is very poor. So then considering these conditions and also getting the near real-time information about the rainfall intensity, and how much is the duration for the rainfall, we basically predict that, okay, these are the areas which are likely to have the landslide. So this is just one example of my last vertical on the governance, basically wherein we are using the Earth observation, the satellite data, as well as the geospatial technology from the GIS, basically to monitor the public benefit schemes. The government of India launches a lot of schemes, which basically benefits the people. It is for their livelihood, it is for their economic betterment. So those kind of schemes, how they are being implemented on the ground, are being constantly monitored using the Earth observation satellites and also the geospatial information. Whether you talk about the crop insurance, which is directly connected to the farmer. So basically, we from the remote sensing data, we really study how much area is really affected by the crop, and they claim what the crop insurance company is giving, or the farmer is asking whether it is really having that kind of match or not. Similarly, we have a program called PMAY, where the Prime Minister of the country has promised that housing for all by 2022. So here also we are monitoring the stages of house construction, every stage. So in 5 stages, the entire house construction is monitored, and then the financial assistance or financial transaction is done based on these kind of outcomes only. So just now, very briefly, I will just touch upon some of the international cooperations, how we do in the Earth observation system. We collaborate with many space agencies, even with the agencies which are developed already, which are very high as far as the technology is concerned, and some of the countries which are developing as far as the space technology is concerned. We join them, one side to learn from them, another side to teach the other country. How we really do the international? Basically, we realize the joint satellite missions. That means 2 countries join hands, and we realize common satellite. We accommodate the payload. Let us say one country has got a payload, but they don't have the capability to really launch, or build a satellite. So we take the payload from them and put in our satellite, and payload of one country, but being flown on the ISRO satellite. Similarly, we do the data share exchange with other countries to help them to get the Indian remote sensing data, as well as if they are having data, we do the mutual exchange also for the calibration. We develop a lot of applications for various countries, help them whenever any country is coming that they need certain remote sensing applications or the capacity building. We do help them, in building such apps. I just wanted to show quickly, like one rice, which is a very famous rice in Bangladesh. So we have helped them to build the technology, really using microwave data, how to do the accurate map of the almond rice in the Bangladesh. This is a joint, or you can say bilateral project, which we are carrying out now almost like past 2 to 3 years, and totally under validation now. Other one based on some of the prototypes in their country. This is one district called Kandy in Sri Lanka, where we have built the groundwater prospect for them. And on the same sequence, one more like land cover, we helped them to build for Sri Lanka. We helped the Nepal for doing the, and then also for Bhutan, basically for the glacial mapping. These are some of the examples, and also to really do the capacity building so that they can operate satellites. And for doing this, this is my last slide. I wanted to show that we have a steep Dehradun, wherein basically provide the professional, the training, capacity building, satellite communication, and global action, psychology to the many countries. We also organize short-term courses because sometimes some countries are interested to have beyond the demand. And we also have the online open sessions recently done for disaster. So where you can see also one event where center which is related to UN. This is a UN center affiliated to nations. And this is my last slide now to show that how now we are working towards building more and more analysis ready data, because rather than giving data to user, we want to give a product so that a user, a common man, can directly use the product. or we can also give the advisories to the common citizens like farmers, fishermen, and many other who can directly utilize the data. Now we are moving from reactive to proactive disaster risk reduction. That means we don't want to really wait, for any disaster to occur. We would like to work more on early warning systems where we can generate the alerts and give. Similarly, we are now working on the onboard data processing. So many of the application products can be directly processed in the satellite, and it can be downloaded at the ground station. So these are some of the newer areas where we are working. Hopefully, in the next 5 to 10 years, we'll have some operational capability in these areas. Thank you very much.
Yes, thank you, Mr. Shantanu. I think now is the time to receive the questions from our audience. One question is asking, can the Earth observation applications data can predict natural disasters like earthquakes? Can it give like an early warning that there will be an earthquake sometime?
No. Every country is so far only building the sort of capabilities to really predict the earthquake. But there are certain precursors, to the earthquake which can be studied. There are certain ionospheric disturbances. Some disturbances are there in the electronic count in the ionosphere. Some disturbances are there in the in the plate movement or tectonic movement. Those kind of things can be studied, and maybe you can exactly say that, okay, these are the areas which are likely to have the earthquake. But actually, prediction of earthquake, like cyclone, that when it is going to happen, at what time it is going to happen, it is still a topic of research, because a lot of work is being done. But so far, no other country has really developed the kind of methodology to predict area.
All right. Another question goes as the data of the Earth observation applications, are they publicly published periodically, or are they private only to the Indian ministries?
No, actually, as far as the remote sensing data dissemination is concerned, in India we have a policy called remote sensing data policy, which was sort of, you can say, made in 2000. That basically policy says that the data which is a very high resolution of something like 1 meter and be scrutinized before giving to all other data sets are given at some cost to the government agencies as well as to the industry. But I just like to mention here, soon we are going to come out with a remote sensing policy. Now, maybe we may publish that policy maybe in the next 4 to 5 months' time after the government approval, where we are making the entire remote sensing data resolution or the cursor will be available on our websites. Anybody can download and use it. And the data which is will be also given or also will be open, you can say, but with some sort of technical things required before giving it to the user.
All right. Muhammad here is asking about the surface area of the Earth observation applications. Is it only concerned with Indian territory? Are there any other parts of the world that these applications are concerned with?
No, primarily most of the applications which are carrying out at operational level, we have done for the Indian region for the land applications and for the Indian Ocean region for the ocean applications. But of course, as I told, we have helped many countries, and we are still partnering with many international agencies also to the global assessment. Like we are now currently working with JEX basically for the Asia rice. So we are doing the Asia rice mapping not only in Bangladesh but also Sri Lanka. We also identified in Bhutan some of the areas. So we do cooperate with many agencies to carry out these applications in other countries as well. But yes, ISRO is very open. If anybody wants to, wants to share our expertise, share our experience in these applications, we're happy to do that.
All right. Faisal here is asking about the satellite's ability to determine the type of soil and if it's suitable for cultivation.
Yes, basically soil type you cannot identify from the remote sensing data. Basically, you can only do the physiography of the soil. You can identify, you can only say that, sort of the soil alkaline or acidic in nature and this. But if we really want to do a very detailed study, we also need to do the soil profiling. So the soil scientist also has to go to the ground and has to take some soil samples. And it is not that inch on the ground he has to take the samples. There is a scientific sort of grid, which is basically says that every few kilometers, they have to take the soil sample, and then they correlate that information with the remote sensing data to generate a soil map.
Yes, thank you. Ladies and gentlemen, that was our last question for our guest today. At the end of our talk, I would like to thank Mr. Shantanu Patodikar, Scientist and Director of Earth Observation Applications and Disaster Management Support Program Office from ISRO, Bangalore. Thank you also to our audience on Twitter and also here our subscriber on Zoom. Mr. Shantanu, thank you very much.
Thank you very much, and I'm very thankful to the Saudi Space Commission for giving us this opportunity. Thank you very much.
Thank you. I also would like to thank the Space Talk team for the excellent work today. And let's remember, space is not a getaway from Earth. It's a way of making our life on Earth better and prosperous. I am Rayah Al-Shahrani, and until next time, this is Space Talk from Riyadh. Good night.
Thank you.